Hello everyone, welcome to the code space. In the last OS class, we have discussed about the types of multiprogramming. We have discussed the difference between preemptive and non-preemptive multiprogramming. Let me just recall again. Preemptive is the type of multiprogramming in which the process can be preempted out of the CPU forcefully when the process starts consuming more amount of time, or a new process whose priority is greater than the current executing process is came into the ready queue. So today we are going to continue our discussion on the multiprogramming, and we are going to see the schematic view of multiprogramming. What is schematic view? Schematic view is a diagrammatical representation of how a process is executed by the CPU. Let me draw a neat diagram of s- states of the process. First of all, a process is created and it is termed as job creation. The first process is job is created, and once the job is created, it will be okay. Now, once the job is created, it will be pushed into a ready queue. You may get a doubt now that what is ready queue? Ready queue is a queue which maintains the processes in a queue on the basis of an scheduling algorithm. It decides which process to send to the CPU next, and all the processes which are ready to execute will be stored in this ready queue. So once a process is created, it will also be pushed into the ready queue. Let me draw a ready queue here. Okay, ready queue. Okay. Now a process is popped out of the ready queue and given to the CPU for the execution. As we know that at a time only one process can be executed by the CPU. So only one process is sent to the CPU, and CPU starts executing that process. This is CPU. Now, a process in the CPU can have can be terminated, or it can, if the process needs any input output operation, it will be sent into a input output queue. Input output queue. There is another queue, input output queue, which maintains the processes which needs an IO operation. Input output queue. Now the process which completes its input output operation will be again sent into the ready queue, and from the ready queue it can again go to the CPU for completing its execution, and once it is executed, the process is set to be executed, completed. So it is known as job termination. Now, each in each state, the process is assigned to a state, like the created process, newly created process, the state of the newly created process is new state. We have given some notations for each state. The process which is just created now is called as a new state, and the process which is in the ready queue is set to be in ready state. and the process which is currently executing by the CPU is said to be in running phase, running state, and the process which has completed its execution is said to be terminate. It's said to be in terminate state. Job termination. Now, the process which is waiting for the input output operation is said to be in block or waiting state. Here's the clear and neat schematic view of the multiprogramming. Now, we can see the process executing by the CPU from going from ready queue to the CPU, but it is not actually what here it is. Actually, the process does not move to the CPU. It stays in the main memory, and CPU executes its instruction line by line. If the first line is completed, it moves to the second line. If the second line is also completed, it moves to the third line, and so on. Now, let me explain the role of MMU. First, the CPU, if assume that the CPU is executed a process, first step, let's say process P1 is being executed by the CPU, P1 is being executed by the CPU, then CPU it executes its first instruction. Let me try it again. CPU executes first instruction, and the next address of the next instruction will be stored by the program counter, and CPU returns the logical address of the next instruction. But here, to access the next instruction from the main memory, we need its physical address, but the program counter maintains the logical address. So this logical address will be converted into the physical address by using MMU. MMU converts the logical address into the physical address. This physical address is used to access the next instruction from the main memory. Next instruction will be accessed and it will be passed to the CPU. Now, you can ask why we are here maintaining two addresses rather than one. It is mainly because of security. Because a faulty program can access the memory of another program. To avoid these type of errors, we maintain MMU. We maintain two addresses. One is logical address and the other is physical address. Once, while converting the logical address into the physical address, MMU ensures that the program does not interfere with other memory spaces. And I just want to say that while executing the program, if the program contains any operations which requires the access of hardware, then CPU will change its mode to kernel mode. Actually, CPU consists of two modes. One is user mode and the other is kernel mode. One is user mode and the other is kernel mode. User mode is responsible for executing the instructions which are related to the user processes or application programs, system programs, libraries, accessing libraries and all. And kernel mode is responsible for instruct to execute the instructions which consists of system calls, access of hardware, access of operating system. The instructions which are privileged will be executed by the kernel mode. User mode does not have access to instruct the instructions which requires the hardware access. A program counter PSB, a program counter PSW, processor status mode, maintains the current state of the CPU. If the mode bit of PSW full form PSW, processor status mode. This maintains the current state of the CPU. If its mode bit is assigned with 0, then it is set to be in kernel mode. 0 for kernel, and 1 implies the current CPU is currently in user mode. And that's all for today. I hope you like this video and you gain something knowledge by this video. So if you like this video, please hit the like button and do subscribe for content related to the OS and the data structures. Thank you for watching.